Hi there, everybody. This is day 2 of areas in the plane. You know what? Let's just get right down to it. So the same idea as the last video, trying to find some areas of some irregular shapes using calculus because we have to. Actually, we don't have to. There's formulas that you can derive, but that's the way we're going to do it for now. So we've got an area here, not a graph of it yet, but bounded by the curve x equals the quantity y plus 2 squared, and the line x equals 4, and it's the area that's inside that. To get an idea of what that looks like, you're gonna have to use your calculator to graph this. Now, your calculator wants y equals, so we would have to solve this for y. Now, when you do that, we'd have to square root both sides. So we'd have plus or minus the square root of x equals y plus 2. And then plus or minus the square root of x minus 2 equals y. So there's actually two things we're going to have to graph here in order to get the graph in our calculator. They're both kind of taken into account when you write the curve like this. But we've got to do it separately in our calculator. So in your calculator, it will look like that. The square root of x minus 2 and negative the square root of x minus 2. When we graph it, I already changed the window. We get that. And it's a sideways parabola is what it is. And the line x equals 4 is right there, roughly. And we want to find the area inside there, enclosed by this sideways parabola and the line x equals 4. So this line inside. So first thing we probably ought to do is find what our bounds are. We can see it's 0. Our bounds for x are 4, so it seems to be pretty good there. And if we use the method from yesterday, we said it's the integral of the top curve minus the bottom curve. The problem here with that is that the top and the bottom curve, it's the same curve. So if you do top minus bottom, it's the same curve, so you're going to get 0, and your method doesn't really work. So what we've got to do is integrate dy. Okay, with yesterday we said that the width of our rectangles was an x quantity, so it's delta x. This time our rectangles are going to go the other way. So our little rectangles are going to have a width of delta y, and the length of them is going to go this way. So we're going to integrate dy, which means we need to have bounds for y. So here's x equals 4 up here. It looks like it's y equals 0. I'm not sure where this one is. Looks like it might be negative 4, but I'm not sure. So let's figure that out. You know that y plus 2 squared has to equal 4. Right, just setting these equal to each other, we square root both sides. 1 plus 2 equals, now that's plus or minus 2. The square root of 4 is positive 2 or negative 2. And then we get y equals, let's see, if it's positive 2 and we subtract 2, that's 0. If it's negative 2 and we subtract 2, that's negative 4. So that's about what we thought it was, but it's good to be sure. So that's where this line x equals 4 and the parabola they cross at y equals 0 and y equals negative 4. Okay, so now our integral. So again, our bounds are for y. We're going from negative 4 to 0, and we're integrating dy. And it's instead of the top function minus the bottom function, it's kind of the right function minus the left one. It's the same idea. If you were turning it like this, the top function would be x equals 4. The bottom function would be the parabola. So you go 4 minus the parabola. This way we think of it as right minus left. So 4 minus y plus 2 squared. And our right curve and our left curve are the same throughout that whole range of y values, so we only have to set up one integral, which we have just done. And let's take a look at another example. Here we want an area bounded by this line, x plus y equals 1, the parabola y equals x squared, and the x-axis. Again, just by looking at this, I'm not sure exactly what that area looks like, so let's go to our calculator and graph it. Clear these out. This one, in order to graph, we're going to have to solve it for y, so that's 1 minus x. 1 minus x. We want x squared, and it's bounded by those two and the x-axis. So let's graph these, see what happens. Okay, so y equals x squared, the line and the x-axis looks like this little sliver of a thing down here. Let's zoom in on that a little bit and let's make that a 1. Negative 1 to 1, I think, is good there. So let's make it 2. Let's see. Let's make this a little better. Let's change that to 0. We'll leave that and make that a 1. Okay, yeah. So it's this. So the y equals x squared. Here's the line. Here's the x-axis. It's this little. It would be a triangle if it weren't for this curved side here. But it's this little part down here. That's the area that we want to find. Now, this one can actually be done dx using the methods that you learned in the previous video in part 1 of this. You'd have to split it up into two integrals, one integral for this one and one for this one, since the top functions are different. This one's actually, you can do with one integral, doing it dy. So this one isn't impossible doing it dx, but it's easier if you do it dy. The previous one you had to do dy. This one is just easier. So let's take a look here. We want to do this dy, so we need bounds for y. Our bounds for y looks like our y equals 0 and y equals whatever this is. Now that's where this parabola and this line cross. So I'm not sure where those are. So where the parabola and the line cross, that would be where 1 minus x equaled x squared. I'm not exactly sure where that's going to be, and we could try to move everything over and solve it by factoring, but it's actually not going to factor. This one we're going to have to use our calculator for. So we'll go second, calc. We want to know where the two lines intersect, so we're going to choose intersect. And it's asking us for the first curve. It's on the line. We'll hit enter. Second curve is the parabola. There we go. And then it's going to ask us for a guess, so we'll move it over and tell it to guess. Whew. And we got x equals about 0.618. And some more, 0.3399. The y coordinate, it was actually what I need, is 0.38196601. Remember, our bounds are for y, so we're going from y equals 0 to whatever this y value was. So it's actually this y coordinate that I needed here. Okay, so let's set up our integral. Now remember, we're integrating dy. That means our bounds have to be for y. We said we're going from 0 to 0.382, let's call it. And it's the right function, or not the right function, the right curve minus the left curve, since we're doing dy. Now the right one is the line. We want it in terms of y. So that's going to be x equals 1 minus y. All right, if you solve that for x, you get 1 minus y. We want this in terms of y because it's dy. So right curve minus left one. And so that is if we solve this for x, we get the square root of y minus the square root of y. So right minus left. And there we go. We could, you can antiderive it, plug the numbers in, and get the area.